Welcome everyone. In today's tutorial, we will be solving fundamental problem number 8 of chapter 2, force and vectors. In this problem, a hook is given, three forces acting outward from the hook at different directions. We will be determining the magnitude and direction of the resultant force. In last lecture, we only discussed the x and y component of the force. So in this video, we will be going more from that video, like we will be determining the magnitude and direction of the resultant force. So for this solution, I will be naming this force as F1, this 300 force as F2, and this 250 Newton force as F3. So I will be finding its x and y component. Like for F1, F2, and F3, I will be finding their x component and y component. I will be finding the resultant x. Like I will be adding F1x, F2x, F3x. And similarly, I will be doing for Fy, like F1y, F2y, and F3y. I will be adding all these to get the Fy. And for the resultant force, I will be applying the magnitude formula that says that the Fx, like all the forces acting on the x-axis, I will be squaring this plus, and similarly for the Fy square under root. So this will be the magnitude formula. So I will be then putting the values. I can find the resultant force, and for the direction, I will be just plugging this formula, like plugging the value of Fy and Fx. We can get the direction. So this is the overall gist. I will be doing step by step. For F1, I will be finding its x and y component. So for this, I will be drawing its rectangular component. We have this resultant force. The x component will be acting on the right, and the y component will be acting upward. So this will be the rectangular component of the 400 force. So this will be F1y, and this will be F1x. For F1x, I will be applying cos theta formula. Cos theta is equal to base over hypotenuse. Here base is F1x. We have this triangle, this is base, this is perpendicular, this is hypotenuse. So I will be applying cos theta formula, base over hypotenuse. Base is F1x and the hypotenuse is F1, which is 400. So I need this F1x. So F1x, shift this 400 to the other side. So it will be 400 times cos of theta. So F1x will be F1x equal to 400 cos of theta is 30 degree. So putting the values, we will get the value for the F1x 346.4 Newton. So we did calculation for the F1x. Now similarly, we'll be doing calculation for the F1y, like for this force. So for F1y, we'll be using, now we need this side. So this is perpendicular. So I will be applying the sine theta. Sine theta is equal to perpendicular over hypotenuse. Perpendicular is F1y and the hypotenuse is 400. I need F1y, so shift this 400 to the other side. So it will be 400 times sine of theta. So the value of theta is 30 degrees. So F1y will be equal to 400 sine of 30. So the value of F1y will be equal to 200 Newton. So for both F1x and F1y, both the value will be positive. Why? Because we know that whenever the force acting on the right, like for the x-axis, if all the forces acting on the right side from the origin, we will be taking those horizontal forces will be positive. And for y, all the forces acting upward from the origin, we will be taking those forces as positive. So here we have these forces as both positive, F1x and F1y. So we found the value F1x and F1y. I will be raising all the calculation, only writing the F1x and F1y because I need this value further in calculation. I have written the x and y component of this resultant force here. I need these value further in calculation. Now I will be doing calculation for F2 force. I will be finding its x and y component. Here we have this the F2 force. Here you can see that we have this F2 force. It's directly acting along the x-axis. So it means that it doesn't have any y component. So for this, we'll be doing the same calculation like F2 for F2x. So the F2x is directly equal to the F2. So it will be 300 plus 300 because it is acting from this origin on the right. So for F2y, for F2y, for F2y, the value will be equal to 0 because here you can see that there is no xy component for the this force. Like for F2 is equal to 300 Newton, there is no y component of this force. So it will be directly equal to 0. Here I did calculation for F2 and F2x and F2y. I will be writing these forces here. So now for F3, I will be finding its x and y component. So here we have this similar triangle technique. I will be resolving its x and y component of the resultant force. The x component will be acting on this side, so this will be the F3x, and the y component will be acting on this side, so this will be the F3y. So here we have two triangles. Last lecture was about the same, that we have two triangles, so we'll be applying similar triangle technique. So for this, the x for the F3x, for F3x, I will be using similar triangle technique that says that base of large triangle divided by base of small triangle, which is 4, equal to the hypotenuse of large triangle, which is F3, 250 Newton, divided by the hypotenuse of small triangle, which is 5. So doing calculation. So now remember what will be the sign, positive or negative. Here you can see that this is origin, and this F3 force is acting out from the origin. It is acting on the left side, so it will be negative. Remember this. This is the main point of this force. So the F3x will be minus 250 divided by 5. Shift this 4 to the other side, so it will be multiply 4. So the F3x will be equal to minus 200 Newton. Now do calculation for the F3y. We'll be using similar triangle technique. Now we'll be taking the hypotenuse perpendicular. So base of large perpendicular of large triangle divided by the perpendicular of small triangle, which is 3, equal to the hypotenuse of large triangle, which is 250, divided by the hypotenuse of small triangle, which is 5. Now what will be the sign? It will be, it is acting upward, so it will be positive. So there is no need to write positive sign. So F3y will be equal to 250 divided by 5. Shift this 3 to the other side, so it will be multiply. So do calculation. The F3y value will be 150 Newton. So I will be writing this value on the other side, on the left side. Here we have found all the x and y component of these forces. So now we will be just adding the horizontal forces to get the Fx, like F1x plus F2x plus F3x, and putting the value F1x. Here we have this F1x, which is plus 346.4. Then F2x value is plus 300, and for F3x we have this value, which is minus 200. So the Fx will be equal to 446.4 Newton. Now do calculation for the Fy, like adding all the vertical values of the forces. So F1y, this is the y component of the F1 force, plus F2y plus F3y. So adding all the values, F1y value is plus 200, then F2y value is 0, then F3y value is 150. So we got the value of F1y, which is 350 Newton. So remember these two values, as we know that the magnitude of the resultant force is equal to square root of Fx square plus Fy square. This is the formula of the magnitude of the resultant force. We found the value of the Fx and Fy. So we will be just putting all the values in this formula. So we will get the value of the resultant force. So plug in the value of Fx square, which is this value 446.4 square, plus Fy, which is 150 square. So plug in these in calculator, we will get the value. We will get the value of the resultant force, which will be 567.3 Newton. This is the answer for the resultant force. Means we calculated the magnitude of the resultant force. Now we'll be determining the direction. Theta is equal to tan inverse Fy divided by Fx. So this is the formula for the direction. Direction is represented by theta. So putting the value of Fy and Fx, so tan inverse Fy value is 150 divided by 446.4. So putting all the values in calculator, we will get the value of the theta, which will be 38.1 degree. So this is the answer for the direction. So theta is 38.1 degree. So it means that the resultant force is acting somewhere here. So this angle is 38.1 degree, and the x and y component of this force, like this is the resultant force value is 567.4 Newton. So the x and y component is acting here, like this will be the y component, and from the origin this will be the x component. So this is Fx, which value is 446.4 Newton, and for Fy it will be 150 Newton. So this will be the Fy. So we found the value of the magnitude of the resultant force and its direction by using rectangular components of the individual forces. So thanks to everyone.